It is time to finish this board. I've been putting together this motor controller board and streaming all of the process live here on YouTube. I still have some videos that I haven't posted yet. I'll post them as soon as I'm done with this board. Those are the videos that I haven't published live from the beginning of the design, which could be useful as well, because I go over the full schematic step by step as I put together the schematic. And I'm going to post those videos as soon as I'm done with this board. But it's time to finish this board. It's almost done. So I've connected all of the nets. I have no unconnected nets. I find that it's quite useful to actually use this function in KiCad that creates nets that have better contrast. So this rendering mode is very useful to be able to see where the net is going. But even though everything is connected, everything is not yet reviewed. And I've been thinking of how would I go about reviewing the PCB. So I had some methods for reviewing the schematic, where I first review the components, one component at a time. So I had a script written in Python that reads the schematic file, dumps all of the components, and then I go through the Excel document and mark each one as green as soon as I've reviewed it. And that process involves reviewing the footprints, the pinouts, the connections, basically everything. And then after that, I had a process where I review all of the labels. So it's all of the connections that are connected through labels. And that proved to be very useful as well, because that pointed out some minor faults that could have been big problems if I hadn't noticed them in time before actually moving on to the next step, which would be the layout. So now I'm in the layout stage, and I want to review every single piece of this board here as thoroughly as possible, so that I can find any faults or any potential faults that could be there. And to do this, I have figured out that I could use the netlist generator here. And there are different ways of generating netlists, but I chose I think it's, let's see, it's actually CAD Star, because I find this format to be easier to work with. And the idea here is that I'm going to dump the netlist in this format, which I've already done. And after that, I'll open this netlist. Let's open this netlist actually in a text editor, so we can see what it looks like. So what we want to do here is basically extract all of the net names and then put them into a CSV file, open it in OpenOffice, and go through every net, selecting that net and checking if that net is properly connected either through the tracks or through copper fills. Because sometimes there could be things like this. If we look at let's look at the power layer here. There could be issues like this. For example, if I have vias and I have a copper fill, there could be places where if the via is placed here, it will actually almost cut off the copper fill, and we want to notice that. And it's very easy to miss that if I just go through this board. For example, if I start here in this corner and I just go to the tracks that are here and then move to the next corner, it's very easy to miss that. So I think it's better to dump the netlist first and then go through every single net and basically check if that particular net is properly connected. So that's what I'm going to do. I have the netlist actually now exported to, let's see, monitor FRP. And here we can see that it's very easy to extract the net names here, because all of the lines that are concerned with nets in this file start with add ter. So this presumably adds a terminal that has a name, and some of the nets are named and some of the nets are unnamed. The problem, so I tried the different formats in KiCad to export the netlist, and I found that, for example, the SPICE format exports the netlist where it replaces the parentheses with underscores. So that's a problem. We don't want that. It's hard to search for the particular net by just copy pasting that into the search box. So this format seems to be perfect. Let's see if we can extract the nets from this format and sort them and filter out any duplicates. So I can just probably do this directly just through the terminal. Let's see. No. Stop recording. Damn it. I always get into this record. Ugh. Let's see. I rarely use macros in Vim, so when it starts recording, it's kind of annoying. Anyway, so we can do like this. So grep add tur from this motor driver to xfrp, and we get a list of all the lines that add the terminals. So that seems reasonable, and we can easily. It looks like every single line follows the same format. So it's basically just columns. So we can extract the fourth column here by using awk. Awk, by the way, is fantastic little language for text processing. It's so powerful. There is actually like a small PDF book that describes awk, and just learning it, just reading through it a little bit, is really amazing. Like it's been around since I don't know, since like 70s. It just for doing quick stuff like this, it's really good. Let's see. I think it's gonna be number 4 because 0 is the full line. And then we should get all of the net names like this, so we can sort this, and we can extract the unique nets. So this seems to be like pretty much we could just pipe this into a CSV document, and we can then open this in Calc. I think we could just see. I'll just open it from the GUI. Let's see here. How many windows do I have open? A few. So this is from the reviews of the labels and the components. And let's see here. If I just drop this file there. Where is it? So nets CSV. Let's see. So this is now all of our nets. And it's not that many nets. I mean, it's like a lot of connections are just ground connections. So even though there were several thousands connections that I had to connect when I started the layout, the number of nets is not that large. So let's get started here. Let's see. So we have 12 volts out. I wonder if I can just search for this net with a slash. That's interesting to know if it supports the slash. It should no, apparently not. So for any nets that are okay, worked for another net, but why is it not working for this? So this is the net we need to find. Maybe okay. So maybe it's because this net is implemented as a copper fill. So maybe it's not finding it because it's a copper fill. Let's see. Because it should find the other nets. Like if we go to just whatever that has a wire. Let's see. This is gonna be hard if this doesn't work. Like, what's the point in having that functionality for searching for stuff if it doesn't work? Let's see. Maybe it's like maybe there's some character there. No. Let's see. Net. Okay. So maybe we can just do it like this here. If I just find this, can I find this? No. No, my plan failed. I had such a perfect plan. Come on. Oh, is there any way to do this? Is there any way to find the nets? Because otherwise this is going to be hard. let's see. What would be the next step here? What could I try or check? If I could only select the net here, that would be very useful. Because if I select it here, that should select it. Maybe that's only for pins. Where's the cursor? Where is the cursor? Come on, KiCad. Don't make this so hard. Oh, there. Right, this is gonna be hard. If I could only find the maybe there is some way. Maybe I'm just missing how KiCad works. Maybe I just don't know all of the details of how KiCad works. Let me see if let me check something. So why is this not finding what I wanted to find? Maybe this is only for components. So maybe it's like, maybe we should actually, right, this would be one way to do it. Maybe if let's see, maybe if I do like this, I think it was one there. I think the first column was the no, yes, of course, it's probably the second one. Yeah. Oh, yeah. And maybe if I could sort it by the net and then keep the component name, so I could at least find the component. I think, let's see, sort column. Is there any column here? I could actually use the unique option there directly. But field, maybe, yeah, field. So how can we sort this by field? So T and then space. This is the most fun of the live stream videos, because there will be detours. Like, I had a plan to do it in one way, and then I found that that plan failed because KiCad doesn't find net names. So now I have to come up with an alternative solution for this. And I'm kind of thinking maybe what is the key def? It is, let's see, for start and stop position, where F is a field number and C is the character position in the field. So maybe if I sort with K 2, this seems to work. Or see if we can find something that's something that I have many copies of. Why do I only have one GND now? Right, I think, okay. Could it be that the FRP file I see. Okay, so the FRP file already actually contains unique terminals. It's just that it then adds connections to many other components, which is fine for the review, because all we're interested in is at least one component which we can search and the name of the net. So that's actually pretty good. So let's sort this by the first key. And export this directly to, let's see, actually, I'm going to make this a comma separated file. And I guess that the fastest way to do this without making any modifications to KiCad would be to do it like this. So I have this net here, and C10451. Okay. And yeah, so let's do it this way. I think this is okay for now. So I'll go through each net, and I'm gonna check a few parameters of the net. So the most important thing here is the thickness of the wire, and 0.35 is sufficient for I think about, could it be 3? Let's double check this. How many amps we can do? Track width, current. Let's just start with current. So we just go 3.5 and just check how many. Can keep the conductor length at 20 millimeters. Yeah, so this is trace width has to be at least 1 millimeter. On the external layers. And what is the current here? Check this. I'm going to check this in electrical characteristics. I want to check the total current of this chip, and I'm going to use the same thickness for all of the supply rails to this chip. This would be for the gate outputs, but kind of looking at this PVDD1, but this is no load on the gate drive output. So could it just be the sum of, let's see. Let's check, go with 2.7, 0.68, and temperature rise. millimeters for these conductors. One millimeter. Okay. have a look at the reference design. Do I need to make these traces thicker? The ones that go here, or is that sufficient? 0.3. So 0.35 should be able to handle to 1.65 amps. But how thick should I make this trace? From experience of using this chip, I can definitely tell that this should be enough. Like, I've never had problems. But now, just because I'm reviewing this, it kind of seems like I should give a second thought to this and decide what should I use actually. Like, what would be the proper thickness of this trace? This one's 0.25. 129. Maybe I should just make it the same thickness as the pads. Okay, I'm going to start with this one. I'm just going to make that one a bit thicker. And make this 0.5. And for the via, this would be slightly bigger via. Okay. I'm going to use what seems to make sense for now, because it's been working fine with even thinner trace, I think. But that question still remains, though. What would be the proper width of the track to use for that chip? So what I'm going to do is just, at least I'll just go through the tracks, and I'll update the sizes of the vias, because all of the vias that are supplying power to this chip should be a little bit larger, and it's going to be probably many such little issues where sometimes I've used larger wires, but it's way too easy to just use the default size. So I'll go to C105. C105. Huh. This track here is a bit off. So let's fix it. Would it even work to use 0.3? That just seems too thick. It's quite likely there wouldn't even be enough space to use this one. Yeah. So for the signal wires, I'll leave them at 0.25. Okay, so C105. Green. C106. This one is slightly off center. It's connected, but it's not really connected to the pad. So it's a good idea to connect it directly to the pad. Green. Come on. It doesn't always work for me to copy from the cell directly. So I have to do it like this. This one is also off. This happens if the component is moved slightly, which I had to do here. But it doesn't appear in the DRC because as far as the copper area that actually connects the track and the pad, that area is connected, so DRC doesn't complain about that. So this component goes here. And this is for the sensing of the source of the MOSFET. Actually, it'd be better to go here. This is the kind of stuff that is easy to miss. And I probably also should be locking those tracks, because otherwise KiCad will just move them around as I move other tracks. Okay, yeah, this one is properly connected. Great. Oh, let's see. Let's do like this. No, that's too big. I'm gonna use the default wire size for these tracks, and let's see, this one also goes here. Right. So this would be the midpoint between the MOSFETs, and I'm just thinking maybe this is actually not optimal in this case. It's better to directly go from here. Let's see. Or maybe not actually, because yeah, this will have to be the same as it is right now. Maybe I'll just move this down a little bit, like that. Move this one slightly away from the copper fills. Actually, away from anything, because this is a voltage sensing track. Maybe like that. All right. Lock. Press L. And now if I move something else here, it's not going to move this track. It's going to move only the track that is not locked. Actually, I think this is still locked. Yeah, because I pressed Ctrl Z, it unlocked that one. Let's see. Yeah, now it's locked. Okay, That one's fine. 1, 2. This is for the second chip, so I'll make this one a bit thicker. Let's make this on top, actually, for now. Maybe you like this. So the only way that this one is actually connected is right. It's connected through this track. Okay, that's good. Could adjust the size here a little bit. Okay. Seems fine. Can lock all of these. 1, 3, 2. TXAN. Perfect. No adjustments needed for this one. Maybe only moving this track a little bit away from the differential pair. But we have TXAN and P. So I'll lock that one. I'll check this one. Yep. All fine. Lock that one as well. C141. Alright, can lock that one. And C145. You can see here that sometimes things like this happen, like where you have a track that's one thickness here and then a little bit of track that's a different thickness here. So this is good to fix. Let's see. I'm gonna route this one around so I can make this, so I can move this ground wire a bit closer there. I think this would be a bit better. And I think this is fine. Yeah. Lock that one. Copy. This is the 5 volts regulator. You can have a look at, let's see if we, yeah, there we go. This is the compensation. So it doesn't really need to be that thick, but it doesn't matter in this case. It's very short trace. Let's make this, let's see. This could be 25. Actually, it could matter here, but I think it would only matter if the tray, if there's a lot of copper here, because then it can offset the capacitance. But yeah, no, this is not going to matter. It doesn't really matter. Okay. Compensation is an estimate anyway. It's impossible to tell exact values for this compensation before the board is actually manufactured. So I think the idea with the compensation is that the board gets manufactured, and then you do measurements on the output of this regulator, and from the measurements you determine the values of these components, and then you update the schematic and the BOM to reflect that. Let's see. So C18. AC20. I think I could probably just move this component a bit closer. Oh, come on. It's impossible to tell if the track is selected when I have it in the highlight mode. Yeah, that's better actually. So I get easy switch with Alt Tab without having to pick the window. Although this one needs to be moved, not that one. Let's see. This one. Okay, cool. Done. This is a good time to review the designators as well. This would be this would actually need to be a bit thicker. I don't think 1 mm is a. That's a bit too thick. At least for the components, for the smaller components. Connect it like that, and continue wherever I can to use a thicker track. Like this. And then because this one wasn't connected, it doesn't get deleted. Cool. Block that one. I think this is the quickest way to make sure that everything is correct on the schematic, because KiCad doesn't really have that good DRC rules, and net classes are also cumbersome to use. And even if such things are used, it's still a good idea to go over every component, I think, because it's easy to discover other little problems, such as the track being wrong shape or being too close to another track. Right, this is vref, so we can just make this green and lock it. Probably gonna disable this for now. I'm gonna hide the power layer so I can easily select things. Okay. A bit annoying that I cannot directly connect a track by dragging it. Do it like this. Right. 53 pad 2. It's this one. Yep. Seems good. Lock it. And C56. Hello, Masood, and hello, Damien. So like here, for example, this is this doesn't have to go there. I think I can just do it like this. Let's see if there's enough space for that. So even that's not necessary. Or no, actually that's the only way. This is this issue that I've seen in the datasheet, where they have the pins connected in such a way that routing is just it's just too hard. You have to go through a via and you have to go around, because you can't route it any other way. This is just the way the package is designed. but I could at least go here, make it a bit shorter. Do you mean like changing the spacing of the actual pads, like editing the pads like this? Why would you want to do that on the PCB and not in the footprint editor? I'll lock that one. Congratulations. Very good. So C57, that's fine. I'll lock that one. And C5. I'll lock that one as well. Looking fine. C63. Come on. It's better. So this goes here. Just like a bit nicer corner here. Now the track is messed up, so I have to go like this. And not even that works. Delete them manually. Oh, right. I actually didn't see the pad there. There is a pad there. So that explains why that didn't work. Okay, that would be fine. And then this one is not really, or is it connected? Yes, it is connected because it was just hiding behind the track. They're all connected, they're just sometimes not completely aligned with the center of the pad. So I correct that. Right. Okay, I'll lock this one. And then 64. Right, pad clearance. Yeah, that could be useful, especially when doing that for specific pads when it's necessary. You can definitely see the use in that. 64 pad 1, so it was this one. This one's fine. And 65, yeah, I have to go back to that track when I get to it. 65. 2. This one. So this one is the encoder signal. Encoder signal B. Yeah, I should probably move that text a little bit, especially on the A there. It gets clipped. No. Something like that, maybe. KiCad automatically rotates the text when the footprint is rotated. Yeah, that's a bit better. Perfect. Now I could have routed this as a differential signal, but because it's such a slow signal, it's not going to be coming like above a few kilohertz. It doesn't really benefit from any kind of impedance matching, but it could still be better, a little bit better, to have it as a differential signal. Let's see. But in this case, it's pretty much also following a similar layout as it would do if this was an actual differential line. So the lines are next to each other. It's just that they're not officially a differential line. Let's see. I'm just going to move this one. I think something happened. No? It didn't move any track. It didn't move any track somewhere around the pads and around the board like it usually does. That's why I'm locking the tracks now. That's the only way to prevent KiCad from messing things up. Yeah, they just won't connect. It's the same thing. When I was laying out USB here, I can drag the differential line all the way, and then to connect them to the connector, I actually have to do that manually. But that's not a big problem. Probably going to improve with time. Okay, so C65, pad 2. This one. Seems good. I'm gonna lock that one. Actually, I don't think I had the track selected. It was just marked but not selected. Now it should be locked. Pad 1, it's this one, yeah. Green. This is pad 2. The crystal. This is for the EtherCAT. Yeah. Just a minor change. Not really necessary to do any changes there. And now I forgot to select the whole track again, because I think it's selected, but it's actually not selected, because this is just highlight, not the selection. So I have to select the whole track and then lock it. C76, C76. This one is just connected directly here, and this is one of those places where I moved the capacitor, but I haven't updated the track, I think. Or have I? Maybe I just don't see it. Maybe it was there. Maybe I should just do like this. Let's see. It wasn't actually updated. It was slightly off center. Off center too. Not really a big issue, but still always nice to have the tracks on connected to the center of a pad, because otherwise it's impossible to have KiCad automatically delete redundant tracks. Just because I can see this issue, I might as well fix it. I'm waiting for better DRC. I think that's more important than connecting whole buses. Altium has very good DRC. Waiting for something similar in KiCad. But reviewing like this is it's kind of the workaround for now, I think. Even though this is not entirely time efficient, it's still pretty useful to do a review like this. And a lot of the DRC errors that KiCad doesn't have any rules for can be discovered and fixed like this for now. Right, so C82. It seems it's time to review the ground. Let's review the C82 first though. It's placed fine, yeah, connects to ground. Now we have all the ground connections. Let's see, so here, this is not intentional. This will need to be, yeah, there we go. Remove corner. Sounds exciting. Gotta check what the footprint looks like. Yeah, it looks like it's better to move the zone outline this way. So okay, I get that zone selected there. Okay, and then this one also needs to be fixed. Corner. And just looking at the ground connections, I'm not going to make any more changes there. I'll just look at the grounds. Right, so this one is on the top here. Make this one also without any thermal relief, because that thermal relief will just heat up and burn. So that's better, and this will automatically connect also to the ground frame, so no need to drag it anywhere. Although, yeah, I could drag it here because it's it'll make this area filled as well. Like that. Very useful to have transparency there. I almost regret I started doing this change. Okay, going back to the ground. So we got another connection to ground here. This is for the brake resistor, and this would need to be on all layers. So let's see here. So got ground there. And we have some components there. And this ground here, it doesn't have any bias. So even though it's connected, it's not a perfect connection. It's better to have bias there, because they also add the path for heat, for any heat that may build up there. I'll just add a few bias here. Shall I follow some grid maybe of 1 millimeter maybe? try to make things roughly symmetric. What is this? This is 0.5. Yeah, 0.5. The ability to do this, just place vias, this was the single best thing in KiCad 5. Most definitely. Prior to that, you had to create like virtual tracks. Okay, and this one as well, so this also needs to be connected. I'm just gonna check, let's see. So I may also put the ground here. Since there's a bit of space there, so why not? And I'm going to connect this ground here as well, using vias. Yeah, that's too many vias. Anything else? I'm gonna redo this. This is have one unrouted net, and it's this one. I think my ground looks pretty good here. Of course, the ground would be nothing without this ground layer. But including this ground layer, I think everything looks fine. Yeah. Also, of course, I'm going to add lines to this one. And also, as far as this one goes, this would be better off extended a little bit. Let's see. Okay, I can finally greenlight the ground, at least for now. So I'll just move on with my review of all the nuts. You can watch the beginning of this video to see how I extracted this list. And when I'm done with that, I think the board is pretty much done. Thanks for watching. Let's see. I'm just going to go over the chat here. I don't want to play, like, crystal at the bottom, that's a really bad idea. Because that means you have to have a via that goes from the bottom to the top. You shouldn't have any bias on the tracks that are connected to the crystal. So, thanks for the tip, but I'm not going to use that tip. Okay, see you next time. Bye.